Greetings, Kerbonauts. This is Kerbal Space Program. I'm Bob Fitch, and this is Real Solar System launch of the Zarya module that went up first for the ISS construction. So it was about a week and a half ago that I was actually working on putting together this Real Solar System setup, and because I didn't have any of the files installed, I had to go and build it up and put in the mods and get the Real Solar System download and put everything in there to make it possible. And when I was done with that, I then started making some launches and some Zarya replicas, and when I got that all put together finally, what ended up happening was I had a 10 times normal sized Kerbin, but I had accidentally forgotten, or not forgotten, but I wasn't really checking my orbital velocities and stuff. And as it turned out, I did a couple launches, one where I was actually on the 10 times normal sized Kerbin without the proper gravity, and another one where I actually launched my Zarya after I had found that I had that problem, and I fixed the gravity and I did it. But I had two sets of videos, or the files, the video clips that go into making one of these. And so when I took the first one and I put it together, I accidentally used the wrong files, and instead of being at the 7,000 meters per second velocity when I was done, I was only at 2,000, meaning I was on the 10 times normal Kerbin. But I didn't notice that at first, and so I posted the video, and some helpful subscribers were like, hey, wait a minute, your orbital velocity is only 2,000 something meters per second. And I looked at it and I went, I edited together the wrong launch. Well, I could have gone back and I could have edited together the correct launch, but that Zarya replica just wasn't quite up to the standard that I would like if I'm going to go and spend a bunch of extra time editing together a video. So instead, I redid my actual Zarya launch, and instead of using the technique of go and pull down various parts that look kind of similar, I used the same technique that I'm using in my project Odyssey, which is to put together a whole bunch of custom-made parts specifically for this launch. So what you're going to see in this is that I'm launching things that have the exact same mass values, the same fuel volumes, the same fuel masses. Zarya is the same mass, it's the same dimensions. It has all kinds of stuff on the outside of it that look exactly like the real thing. So this is going to be pretty cool, and this was a lot of fun for me. Now, unlike what I would normally do in a situation like this where I launch something and then I take you to the vehicle assembly building and I show you how it was put together, a real solar system launch is really long. So what I'm going to do instead is we're going to go down to the VAB and take a look at the stage that we're working on, and then go see it as it decouples away, and then go back to the VAB and see the next stage and then decouple that away. And we'll do them one by one until we get to Zarya, and then we'll take a little in-depth look at what went on in there. So let's go down to the VAB and look at the first stage right now. So here we are in the VAB looking at the bottom stage, and if we pull off of these FASA pack clamps, we can see here that we have 6 engines surrounding on liquid fuel too, by the way, surrounding a bunch of oxidizer tanks through the middle. And then above that, we will work into our little mesh decoupler there. Don't lose the engine. So we have that little decoupler, and then the next stage up there. So to start ourselves off, you can see that I had those 6 engines around there. Those came from the Bobcat Soviet pack. The whole thing was supposed to be about 7 meters wide, and it was, with these tanks right here that came from KW. However, those were not the basic KW tanks. Instead, I had scaled them so that they'd be about 1.65 meters wide. Because this middle one over here, this one is about 4 meters wide. In fact, the whole thing is about 4.1 meters wide. And that's exactly what I have as well, because I've scaled the whole thing all the way up. You're going to find that I have a whole bunch of scaled parts for everything. So on there, those 6 engines, they came out to about the exact same thrust as the real engines. So you can see here that I've custom built my own RD0253 with that Bobcat engine. I've given it a thrust value of 1650 so that all 6 of them will come out to the proper thrust for this lower stage. It also uses UDMH and NTO4, which is of course unsymmetrical dimethylhydrazine as well as dinitrogen tetroxide. Now, the way these normal engines would have been set up if I was just using Real Solar System is they're a little bit off on the amount of fuel that they're supposed to consume. The way that the realism overhaul works, I guess, or the real fuels or wherever these values are coming from, is it had it set up with a slightly different ratio here of how much it uses of the fuel versus oxidizer. And I wanted it to be realistic, like the real one uses a 2.6 or close to a 2.61 to 1 ratio. However, that's in fuel mass. And so the normal engines like this wouldn't be set up correctly. So I had to switch those around, and instead mine uses about a 58.8% to 41.2% ratio of those different fuels. It's a slightly off from the way that the realism overhaul works, but more accurate in terms of the ratio. You'll also notice up here that the total mass of the entire rocket at launch is 692.3 tons. That's not exactly what the real one was, but it is really close. Like you can see up here, the Zarya itself is 19.3, and that's what mine is. And you can see all the other stages as well. This is like with some fairing on there, and then we got stage 3, stage 2, stage 1. And those are very, very close to the real deal. Also, these thrust values, 1.46 thrust to weight ratio, 0.99 for the next stage, 0.04 for Zarya itself, 0.98 for stage 3. That's all very close to the actual values of a launch. Anyway, if we do my usual technique of let's pull off the engines here and you can see what's going on, well, we have those fuel tanks. Those are the actual fuel. Up the middle, we have oxidizer tanks with that bottom one having those retro rockets to help pull it off while it's launching. Each of these holds a certain amount. You can see right there, 52,554 units of N2O4. The ones on the side were the UDMH, and then we get up here to the fairing that brings us up to the next stage. So let's go out and see more of the launch. And here we are back out at the launch. Now you might be noticing that there's water all along there. Yes, we are on a shoreline. And even though this was technically launched from the Baikonur Cosmodrome in Kazakhstan, Site 81, on November 20th of 1998 on a Proton K rocket, well, it just so happens that in this RSS, I cannot seem to get it to switch over to that particular launch site. I tried 3 times to get it to move over there, and every single time it would crash the moment I went out to the launch pad. So I was forced to launch, unfortunately, from the default launch site, which I believe is down in Florida. Well, oh well, at least it's still a fairly good replica of the actual launch, even if it's not from the proper location. Okay, so I'm going to try to guess what some of the different things people are going to post in the comments might be. Let's see. You're going to say, what are the mods that you used in order to do this launch? Well, if you just follow the link down in the description, it's going to take you to the list of all the mods that I use for Project Odyssey. And pretty much, I pull from the same list. The next question. May I have the craft file? Well, the answer is yes, you can. If you look down in the description, again, you'll find another link, and this link is going to take you to a Dropbox file that is a zip file of all the parts and everything that I needed in order to make this. And you're going to need that. You're also going to need all the parts that it references, because I do a lot of scaling. Now, nothing is actually customized where I needed to put in any models or any textures. These use things that come from existing mods already. However, it's not going to be quite as simple as just drop it in and everything's going to suddenly work. Anyway, I'll get back to that in a second, because as you can see right here, we are decoupling that lower stage and powering up our next one. This is stage 2, so I think we should go down into the vehicle assembly building and take a look at what goes into stage 2. Okay, for stage 2, we have at the bottom here, I have repurposed an engine from the Soviet pack and formed my own RD0211 engine with 28.4 thrust. And you can see I've fixed up the UDMH and N204 rate on the consumption. I've set the ISP values similar to what they ought to be for the real engine, rescaled it a little bit to give it the proper dimensions, and then we stuck that on the bottom of a couple tanks here, where these tanks together form, actually, let me put this back on here again so that I can right click on them. So they form the two different types of tank that would actually compose a launch. At the bottom, we have the fuel, the UDMH. Above it, the second tank was the N204. So just like in a real launch where they separate the tanks, I did that as well. We also have this flag that comes from the FASA pack. I put that on the side of it and I scaled it up to make a nice big Kerbal flag. Let's see, what else is there? We had, of course, on the side of it, more lights. And that's basically it. We'll be moving up into this one when we go to the next stage, but you can see we have that fairing there, and then that's stage 3. So we're going to come back to that in a minute. The last thing that I might mention is, as you saw, that mass value and the thrust to weight was about accurate as far as the real launch goes, and we'll come back to this in just a moment. Because for right now, that stage 1 is falling away where normally it would fall down in the middle of nowhere over Russia. But in this case, it's falling down in our ocean. Meanwhile, our stage 2 is making its way up to orbit. Well, this is going to be a long burn because in real solar system, things take a very long time. The amount of time things take is particularly troubling when it's something that's failing about 10 minutes into your launch, which means if you don't make it until then before you find out that you've had a problem, you're going to be doing that first 10 minutes over and over again. The next thing you know, a whole hour, 2 hours have gone by of you just trying to get into orbit and still not making it. It can be a little bit frustrating in real solar system, and I can understand why when the developers made Kerbal much smaller, why they did that. You really need to want to have a lot of realism in your launches, or maybe just be a masochistic glutton for punishment. I don't know, but let's go take a look at a little bit of what went into trying to get this launched. In other words, let's go see some explosions and failures. On this first one that I'm about to show you, what's going on is every time I took it out onto the launch pad in order to just see what it looked like out there, it was spontaneously exploding. Eventually what I figured out was that if you don't fill some of the stretchy tanks that I was trying to use with fuel, then it must calculate that the mass value is 0. And anything that has 0 mass, as I found out while making Project Odyssey, it has no structural integrity. And so when you get anything that puts any kind of pressure on it, like the upper stage, then it just immediately explodes, and of course, bad things follow. So here, take a look. Failure number 1. You can see that the payload was exposed right there. I only put on half of the fairing, so that when I went out and watched it on the launch pad, if it were wiggling or anything like that, I'd be able to see inside the fairing without needing to zoom my camera in or anything. Also, another thing at this point, even though there's not supposed to be any people on board, I have a couple Kerbals in there just because there's enough room in that module there for 2 Kerbonauts. And I'm just not bothering during these simulations and these tests. Oh, hello there, solar panel. Yeah, so I recorded this one because look at what that solar panel's doing. It was just spinning and spinning and spinning, and this went on for a very long time. Anyway, the 2 Kerbals, I'm just not taking them out yet during the simulations because I figured, you know, well, it doesn't matter. This isn't really launches. When I'm doing the real thing, I'll take the Kerbals out, and we'll worry about it then. For now, it was just trying to find those bad mass values in all of these failures. I will come back and show you some additional failures in just a little bit. For right now, we're going to head back out here, and you're going to see that there are some glitches now coming up. We have that water that seems to be flickering just a little bit, and then all of a sudden, bam! it goes away and gets replaced with a different texture. We must have gone over some magic line, some magic threshold, where the clipping, the mip mapping, who knows what it's doing, where it just decided you were going to use a different resolution texture now, and so away it went, and the water doesn't look as stupid anymore. However, the clouds or ground or whatever it is, it's very blocky. Maybe I've got the wrong resolutions or something installed. I'm not quite sure. I'm not going to say that I'm a big fan of this, though. It seems like probably need more RAM devoted to actually putting these textures in there. Unfortunately, this was already, even with active texture management, running very, very close to the 3.8 gigabyte limit of a 32-bit application. Anyway, we're going to continue with our launch here. We're on the second stage still, and we are about on a 51.6 degree inclination. And this is what I'm going to try to maintain for the rest of this launch, because that's what it was when the real ISS began its journey as the Zarya module going up there. Also, we're targeting about, somewhere in the 300 to 400 kilometer range, I think. Now, depending upon the source that you read, you might see that it was launched originally into anywhere between a 200 and 300 kilometer orbit, or even a 400 kilometer orbit. I'm not sure exactly which one it was, but I'm just doing whatever looks cool in Kerbal Space Program. I'm trying to get really, really close, but you know, it's not going to be 100% perfect, so I'm not worrying about it being perfect for that reason. In fact, you might have seen as I was going along here that the gravity turn may not have been quite right at different times, because this is not being done by a computer. This is being done by me, by hand, in the game, with the controls. So, you know, it was a little challenging at times, keeping it on target. Anyway, we're dropping stage 2, which means now it's time to go into the VAB and take a look at stage 3. And here it is. We are using down here on the bottom my customized RD0213 as well as some RD0214 little mini engines. Now I believe the way that I read it when I was looking out trying to research this on the wiki was that these together comprise a 0212 assembly. Technically the way this is supposed to work is this is one whole thing. Now I've got it set up with this KW rocketry part and the engines are all on there together. The real deal is a little assembly that has all 5 of these engines together at the same time. If we take a look over here, you can see my RD0213 has only 582.1 thrust. That's because when you add in these little ones right here that each have, let's see, 30.98 thrust. You add them all together and this whole assembly has the proper amount of thrust for that last stage. Now, if we continue working our way up, in this case, I did not use the 2 different fuel tank system. I actually allowed it to have both the liquid fuel and the oxidizer in the same one. Now, if we take those away, that's basically it. Now, the next step is to move into the fairing. That used a procedural fairing with a total fairing mass that was very similar, actually, to the real launch. And we will come back to this one in just a bit. For now, we're actually going to go out and get to see a little bit of the Zarya launching for real. We're back, and I had just dropped stage 2, and now on stage 3, we're releasing our fairing up here at 188 kilometers above the surface. We got a little bit of shake there, have to throttle down a little bit, turn off the SAS, and then throttle it back up once it's under control. That was just a little quirk of Kerbal Space Program. Once it gets that oscillation, if you turn off the SAS and lower the throttle, it will fix that and go away. That oscillation will go away. When you throttle back up again, it will come back if you have an instability in the rocket, but otherwise it may actually stay completely fine. So before the break into the VAB there just a moment ago, we had been talking about the gravity turn, and the gravity turn maybe wasn't quite 100% accurate because I had to launch this and make it launch successfully, and sometimes it can be a little hard to get it through the atmosphere. In fact, let's go take a look at some of the failures trying to get through the atmosphere. Oh my. Our first launch here started off okay, and I was a little optimistic that I'd make it higher than I actually did, but it was only about 1,800 meters before it was swaying back and forth and shaking all over. The payload needed some struts, so I decouple it just to check the staging and make sure that if this had gone higher, that all the staging would work properly. Throttle up some of those engines just to make sure those are working properly, because these simulations here can be fairly useful. If you notice that it's starting to fail, instead of just saying, oh, forget that, abort, go back to VAB and fix the problem I just saw, look for multiple problems all at the same time. Here I'm checking to see whether or not the fairing releases and the payload and everything like that. I was able to take a look at the engines down there, fire up the engines on the Zarya itself, the engines that were on stage 3, checking to see whether or not they were capable of vectoring properly and all that. But ultimately, this payload is destined for the ground. It was during that launch, though, that I was able to see a few problems, one of which was that the engines didn't seem quite right on some of the stages. So I decided to bring them out here and just check to see how they were doing. This is the one where I noticed that the N204 and the UDMH were not being consumed at the proper rate. Had to make a tweak to the config file that defines how much this uses, but then once that was done, I was able to bring it back out here for a second test, take a look at the fuel consumption rates right here, and see that now they were actually being consumed properly. So now the engines are actually good. However, the engines aren't good on the lower stage here. Those are nice, bright, white, blue flames, and they have a sound that is not at all like the one I really wanted. So at this point, I decided to make a change to the Hot Rockets mod and put my engines in the Hot Rocket system. Also, we were using this in order to test whether or not the fuel flow was correct for the bottom one here. I wanted to make sure that the liquid fuel and the oxidizer in stage 1 ran out at exactly the same time. Once that looked good and the Hot Rockets mod was all set up, then I brought it back out much higher up on there so that I could watch the flames come out on that first stage and just see how well Hot Rockets had done to making it look the way that I wanted and sound the way that I wanted on that lower stage. Ignite the engines, throttle up, decouple, and listen to those engines. That's how I want them to sound. But uh-oh, look at the top of the rocket. Left and right. It's definitely going to sway all over the place. Oh, look at that fairing. It's starting to wiggle really badly, and we're barely off the ground. We're 700 meters. Yep, this one is going to go poorly. Made some more changes and did another launch test to listen to the sound. Yep, that's the basic first stage sound and look of the flame that we want. However, when I tried to decouple it, then this happened. You'll want to note here that even though I have throttled down stage 1, stage 2 is supposed to be throttled up. So we have rubber band rocket going here because it won't let go. Oh, there, it finally let go. But how do you like those flames? Pretty good, huh? Yeah, there's no flames at all. That thing is horrible. Something's busted with it. So now I have to go back in and fix that assembly, not the assembly, fix the config file one more time to try to get that new engine there for the stage 2 working properly. But we're going to come back to some of those a little bit later. We were up here putting that Zarya into its final orbit on stage 3. Whether or not our gravity turn had been really good or maybe not so much, nonetheless, we are going practically horizontal now, and that's all that really matters as long as none of that thrust is going into fighting gravity. Well, we're a little bit off. There's a little bit going into fighting gravity because it so happens that because of that improper early gravity turn, I'm still needing to try to keep up my altitude in order to keep getting higher up here. There's a good shot of the engine in the back right there. The majority of the thrust coming from that one in the middle, but the four around it, called Vernier rockets or Vernier motors, whatever, they have lower thrust but incredible vectoring capability, allowing me to keep control and point it in the right direction for this orbital insertion. Back at the beginning of this launch, I was still giving my intro when we were rising up through the atmosphere, and that didn't give me a chance to talk about one of the things that I wanted to mention while we were doing that. So when you're launching through the atmosphere, especially in something like Ferrum Aerospace, which is what I'm using right here, there is a quantity called, in real life and in Ferrum, called Q. Q is essentially half of the atmospheric pressure times the square of your velocity, and it generates a number, and as you go faster through the air, squared, remember, so your velocity plays a huge part in how bad that number is going to be, that Q value. As you go faster, you're eventually going to reach a point where the atmospheric pressure starts to drop. So even though your velocity is going up, you're going to hit the maximum value that it's going to be. When you get into space, it's going to be 0. And when you're down on the ground and you're not even moving, it's also going to be 0. So it ramps up and then it goes back down again. That peak point is called max Q. And going back to that beginning of this launch, you can see over on the side I have my FAR flight data, Ferrum Aerospace's window there, and in the middle of it you can see the Q value. Look down from the side there, see there 1, 2, 3 lines and a space, 2 lines and a space, and then Q. And currently it is passing through max Q right now. Notice that now the number is going lower again. So we have gone through the atmosphere's highest dynamic pressure. From here, the pressure on the vehicle is going to go down, so it actually becomes easier to launch from this point forward. But max Q is well behind us now, and in fact, we're running a little bit low on fuel in stage 3. Any moment here it's going to run out, and then Zarya's on its own to complete its orbit. Now, I don't think this is exactly what was supposed to happen either, but I did have that little bit of trouble launching, and honestly, I am so deep into the launch now, there's no way that I'm going back and doing this one all over again. So instead, even though our periapsis is negative, we're going to throttle up Zarya's main engines itself with its 4 thrust, its 4 kilonewtons of massive thrust for its 19 tons of payload there, and we're going to begin burning our way on those little engines to complete this orbit and put us up into the final orbit of 300 to 400 kilometers that we're really looking for. I would say right now is as good a time as any to finally go into the VAB and take a look at Zarya. And there she is. There she is. The Zarya in all her glory. Look at that. Look at that. It's amazing. I found some really good reference material online, and here's a couple of the pictures that I used. And then this one, this was just amazing detail to find these images of the outside of what the Zarya module should look like in every single direction. I used these to put all the little bits and pieces and knickknacks all around the outside. The majority of the parts you're going to see here come from all over the place. I have different things like the Soviet pack for the docking ports and KW rocketry pieces that I have rescaled to make them fit in all the appropriate ways. All kinds of little lights and knickknacks and sensors all over the outside. There's just honestly way too many of them for me to go through them one by one. So I'm going to pull off large sections at a time to show you what's going on with all these different bits here. We have all these different things, you know, the sides there where you can grab onto the railings. These are the engines that I put onto it. Those come from LLL, but I have redone them to be the KRD 442 engines, which I believe might be the ones that are on the side of the Zarya module. It was really hard to find out whether or not those were the right ones. I searched everywhere online and I couldn't find anything except in that one picture. I think I saw that it said 442 in it, so I looked it up and I found that KRD is a type of engine and 442 is a model, so I decided that that might have been what was it. Plus the thrust value was very similar to what I think was on the Zarya, so I think I might have gotten the right one. Also, these boosters here come from the Soviet pack, but they point in the wrong direction. However, they were the closest thing I could get. I think they go on a mirror, but they were pretty close, so I'm using those. We have Cosmos for the fuel tanks, which I have filled all those fuel tanks with N2O4 and UDMH, just like on the real deal, because that's what these engines work on. We have various sensors, like I think those are some sort of solar or earth sensors. This is a panel for filling it with fuel. There's different fuel tanks under all over these places. There are so many antenna on the outside of the Zarya module. It's crazy. There's like antenna here, antenna there, another antenna there. I'm like, how many antenna are on this damn thing? Okay, so anyway, there's these different things all over the sides, and we got this thing here, and more fuel tanks, and the solar panels come from the near future propulsion. We got these are, let's see, where did I get those? No, those are from near future, but I had to scale them up to cover these fuel tanks here with radiators, but we got more of those and more of those, and they're just all over the place. More antennas and different barriers to prevent things from getting bumped or something like that. We have our little things there for them to grab onto all over the place. I have the passive docking ports up here and here, and a little thing to stick it onto right there. This is it's supposed to be a camera. I'm using a light, but it's supposed to be a camera in order to watch the docking of anything that's coming in and docking here or whatever. And then we got some more of those mirror things on the side there. This is supposed to be a clamp where like the robotic arm could reach out from the space shuttle and grab onto it. So there's supposed to be something there, and I used this to represent that. We have a tank back there, a high pressure tank. Let's see, just various sensors and things like that all around the outside, all kinds of sensors. Look at all those things I had to put on there to make it just like those pictures I showed you. And finally, this is the Porkworks Habitat Module, spherical module. So now let's go back outside. Back outside right here, that is, where we have fired up those KRD 442 engines I was just talking about, and we're trying still so desperately to take that tiny bit of 4 kilonewtons of thrust and propel this 19-ton behemoth into orbit. In our world, for the ISS, even though the Zvezda was supposed to be the module that went up first, delays and pressure from NASA made it where the Zarya was actually the first one to go up. Not only that, but it was only supposed to be able to live for about 6 to 8 months in orbit before it actually got docked up with something else. And in fact, because of more delays, what really ended up happening was it went for almost 2 years before anything else came up there and docked up with it. So that was a very survivable module, although I suppose it was tried and battle tested by being very similar, I think, to something that was used in the Mir space station. As far as I know, actually, the only real glitch was that they had a problem with the battery circuits when it first got up there, but they got that all figured out, and it lived just fine after that for the next almost 2 years. Now, in my case, it was not exactly the smoothest launch. We had a few more glitches than that. After I finish popping out the solar panels here, I think we'll go down and take a look at some of the other failures that I had happen. This is what it looks like when the dynamic pressure and the instability in your rocket coordinate together to provide a most interesting initial launch. I knew right here this one was not going to go very well, but I decided to see how high up it would go and just how badly it would bend and where it would bend and what I might need to fix or strut together or who knows what in order to get it to work. And over we go. Wow, that thing is practically bent in half, and there it is. There's the final failure. Now it's basically just going to snap in half or something. So once again, this was me testing all the different stages. Let's just see if the engines throttle up properly. Right there I could see that the flames were coming out from up too high. So I went back to hot rockets and I fixed the flames to make them come from a little bit lower. Also, then we stage away and check that one again to see how that's doing. And the same basic ideas earlier. Try all the different stages as it's failing. In fact, that one had taken the stage 3 engine with it, the second stage when it decoupled, and so I had to go and make another change in order to make sure that the engine wouldn't get stuck down in the second stage. Some attempts would go higher than others, some would go further, some would go faster, some would get to higher dynamic pressures than others. Ultimately, it was mostly a step forward and 2 steps back, and then finally it was 2 steps forward and 1 step back. But it was launch after launch after launch that I was trying to figure out all the different things, working from my way up from the bottom up to the top. It had started out where all the problems were down in stage 1, and then it was stage 2, but every time I was getting a little bit closer, so with each launch I knew that I was that much closer to actually seeing this thing finally in orbit. So we launch again, and we go and start going 2 steps back here where we're just falling apart right after launch, and we launch again, and this one flips over just barely off the ground and does the thing where it's got that rubber band in the stage 2 and the decoupler won't come off, and so we launch again, and we launch again, and we launch again, over and over again. I'm showing you all of these just so you can get an idea of exactly how much effort goes into trying to make some of these launches. This is only a fraction of the time. The length of this video, it's just a bare fraction of how much time actually goes into making one of these. This one I couldn't get it on the right trajectory, and so we started burning up in the atmosphere. Another one where the high dynamic pressure went up over 30,000 Q, which is definitely too high. Anyway, we're back almost in orbit. You can see that we've actually got our apoapsis now pretty high up there. The periapsis has put us basically out of the atmosphere. Now it's just a matter of time. Any moment we'll actually have this up at the 400 kilometers that I'm trying to target. When we were in the VAB, I showed you all the little bits and pieces that went into making this module. Well, actually, there was an attempt to try to weld it together. Let me go take a look at that and let you see exactly what happened when I tried to weld it. Okay, so when you weld a part together, it will go down here. You can see my simple part filter here, my simple part organizer. I have selected to only show my own parts. Felborn is my login name for a lot of different things. And then UBO welding, and so that's all the parts that are showing up are things that I created. So you can see all the different fuel things and the engines that I did. Did I do any others? Yes, those things there. And this decoupler thing that you saw earlier, that's actually one of the welded. There's only 2 welded parts, and that was one of them. I customized the solar panel and the flag, and that's about it. But over here, you can see if we scroll back just a little bit and pull one of these out, this is what it looked like after I welded together. Let me move it up here and put it on top. There we go. So that's what it looked like when I was done welding the thing together. If we pull this down just a little bit away from the rafters, you can get a good look at it. All the parts became all crazily scaled, and there's all these problems with gaps. And this happens all the time when I'm welding things, but in this particular case, there were so many parts in this that I just could not stomach the idea of going in and trying to fix all the scales and positions and everything to make this right. So instead, we launched the many different parts version of this module. And so that's what you got to see here when I took it apart and showed it to you. and that is just about it. This module is almost in orbit, and despite all the many little glitches and how long it actually takes to do anything in real solar system, we're almost there. Imagine if I had done that entire Project Gateway, the whole ISS reconstruction thing, using a real solar system, and all the launches took this long. I never would have finished. It would have been crazy. I'd have been going crazy. So rather than go crazy or die of boredom, I'm going to speed up the last part of this because 4 kilonewtons is just not very much thrust. Actually, I think it was 4 kilonewtons per engine, so that actually technically makes it 8 kilonewtons for the whole thing, but still, it takes a long time to move anything that's 19 tons using 8 kilonewtons. So things here are sped up to 10 times normal speed. All it takes is dedication. We are in enough of an orbit that all we have to do is keep pointed in the right direction, move up to our apoapsis, and then circularize there. We'll bring the whole orbit up. So now we're sliding off here over the horizon and into the darkness, where some of this is now going to be in the dark, but it won't be long until we're in the light again and all done. Alrighty, Kerbonauts, that's about going to do it for this very long real solar system launch of the Zarya module. We have gotten ourselves into orbit. We have a very nice apoapsis and periapsis. It's a pretty good orbit to cut it off here and say, this has been Kerbal Space Program, Real Solar System, Zarya. I'm Bob Fitch. Until next time in Project Odyssey, or go back and watch Gateway, I will see you later, Kerbonauts.